minutes. Hello, Providence, Rhode Island in the house, and Charlotte. Sweden, it's midnight. Wow, love the dedication to furthering your craft and leveling up your skills. I commend you for being on at midnight. I would be passed out, but happy to have you here. Good evening from New York. Awesome. We'll give it one more minute as folks join in. All right, perfect. I'm going to go ahead and kick us off this evening, morning, super late evening if you're in Sweden. Welcome to our Kubernetes session. Hopefully you have signed in expecting a fabulous talk by a couple of women from VMware in partnership with Women Who Code Cloud. I think Kubernetes is a really hot new way to develop applications, but it's really important for us to understand why we might want to build our services on top of Kubernetes and how exactly we build really scalable and consistent user-friendly services on this cluster management tool. So if you are interested in those two items, you're in the right spot for our Kubernetes for Beginners by Nikitha and Aparna, sponsored by Women Who Code, or hosted by Women Who Code Cloud and sponsored by VMware. A couple of housekeeping items. If you have questions throughout today's session, please feel free to use the Q&A in Zoom or use your Zoom chat. When you are chatting, if you want it to go to everyone, switch who you send your chat to from just panelists to all panelists and attendees so that everyone can see your questions and responses as well. Hi, my name is Bree. I'm a Master Software Engineer at Capital One by day and a Women Who Code Leadership Fellow by night. I co-lead our cloud and Python tracks, and I'm really excited to offer this event to you all. Before we get into the main content for our session today, quick little background about Women Who Code for anyone who may be new to our organization. Women Who Code's mission is to inspire women to excel in technology careers. We have this vision where we see a world in which women are represented equally across the technology landscape, whether that be as executives, founders, board members, software engineers, and venture capitalists. We are really trying to move the needle on creating an equitable and diverse industry. Our target for our events, the offerings that we present to our members is usually engineers with 2 or more years of experience looking for support and resources to help them level up in their careers. But anybody who is excited about furthering our mission and vision and growing in the tech space is welcome to participate. Along that note, a general reminder for any and all of the events that we hold, the digital spaces that we occupy, our code of conduct is in play. To sum it up, it says Women Who Code is an inclusive community, and we want to provide an empowering and uplifting experience for absolutely anybody, regardless of how you identify. We do not tolerate harassment of our members in any form. And should you want to read this code of conduct in its entirety or need to access our incident report form, you can do so at womenwhocode.com/code of conduct. I would be remiss without saying a big thank you and making a big plug for one of our sponsors, the sponsor of the Cloud Track, VMware. We cannot host the events and do all the great, amazing things that we get to do throughout the year, offer you all incredible resources without the support of our corporate sponsors. So really big thank you to VMware for being the Cloud Track sponsor and the sponsor of tonight's event, providing us with two amazing speakers. Last little bit about Women Who Code before we jump right into things. Ways to stay connected. If you haven't already, if you're in social media space, follow us on Twitter, Instagram, Facebook, I think LinkedIn coming soon, Women Who Code Cloud. We post resources as well as updates about our events, reminders for you all. Join this track community, womenwhocode.com/cloud. That is also hopefully where you found our events page where you can register for all the events. We keep that up to date along with our social profiles to bring you lots of great content. There's so many good things in the works, from an AWS study group re-kicking off, machine learning on Azure, consulting panel about being a consultant in DevOps in the cloud space. So lots of great events that you want to stay in the know with. Our page and our social channels are going to be the best way for you to stay up to date. If at any time you need to reach out to myself, have a question for the track, have a question for our speakers, feel free to email cloud@womenwhocode.com. And should you want to rewatch this session, missed a previous session, or sad you're going to miss a session coming up, we do have a Women Who Code YouTube channel, and there's a playlist of all of our past events that we hold. We dropped the link to that in our Slack channels for easy finding, but you should be able to Google Women Who Code on YouTube and pull it up. If not, email us. And last but not least, we have a very active Slack community. There's a book club going on in it, lots of great discussions and encouragement. People are dropping new events happening all around the world all the time. So I strongly encourage you to join our Slack community. I will drop the link in chat if you aren't already a member, and we'd love to have you and drop in and say hello. So without further ado, we have two amazing women to give us a deep dive into Kubernetes, the how and the why. Aparna is a director of R&D at VMware. She currently leads VMware's Kubernetes platforms, and she was a founding member of that platform team. She has over 15 years of broad experience in building scalable, multidisciplinary teams, and has launched successful services across data centers and cloud services that involve natural language processing, machine learning platforms, just a whole ton of really good experience that I'm grateful that we have the opportunity to hear from her and learn from her, past experiences. She is passionate about creating and developing inclusive teams where people feel they belong, right up the Women Who Code alley. Nikitha is a product manager at VMware. She works on all things virtual machines, containers, and Kubernetes. Prior to VMware, she was a software engineer and product manager at various software as a service startups. Thank you, ladies, for joining us today. I'm super personally thrilled for this talk. Kubernetes is something that I keep being like, I really need to start to dig into this. So I'm excited to hear from you, and I'm going to stop sharing and quit talking. And I just turned myself on mute before I finish. The floor will be yours.
Thank you, Brianna, for the amazing introduction. So let me just go ahead and share my screen here. Okay, hopefully we're good. So everyone, thank you for attending. So this session is going to be talking about why Kubernetes and how to develop applications for Kubernetes. So if we just look at the agenda real quick, we're going to start by really explaining how the evolution of application deployment has happened over the years, and then really dig into what is Kubernetes and why it has blown up so much, look a little bit at the ecosystem and see what Kubernetes is being used for today. And then at this point, Aparna will take over and give us more details about how to actually get started with Kubernetes, and then we'll dip into some resources that might help as well. I think we don't expect to speak for longer than, I would say, like 45 minutes or 40 minutes or so. So we should have plenty of time for Q&A in the end. And of course, please feel free to drop questions in the chat or in the Q&A section, and either one of us will respond. So really quickly, just wanted to get a sense of how many of you are familiar with Kubernetes, or how many of you are coming into this, and this is totally fine either way, by the way, with not much knowledge about it, just so we can tailor this to meet your needs. You can drop this in the chat if you feel more comfortable that way. No enough to be dangerous. I feel like I'm the same way. So just for, I only started working with Kubernetes when I joined this job at VMware. And so it's been about 2.5 years now. And I can honestly say that, I still feel like I don't know everything about this. And that just goes to show that this is such an interesting topic with so much depth. You can learn as little as you want to, or really go as deep as you want to. And for what I do, I think the knowledge that I have is probably gonna help understand at least the basics, and then Aparna is really more of our technical expert. So anyway, if we head into our slides here. So the evolution of application deployment, right? So I think one of the first stages of apps and how they were deployed was a really monolithic VM-based model. And so a monolithic VM-based model in its definition is basically a single process that is componentized with internal layers or libraries all inside a single virtual machine. So if you wanted to scale the application, all you would really do is like clone multiple virtual machines that were really all running the same thing. And this worked really well for quite some time. And I think the next transition really happened when we moved to a more microservice-based application architecture. So I think the way I like to understand microservices is like you group together the things that change for the same reason and then separate the things that change for different reasons. So that kind of, to me, explains the model that we kind of moved to from this monolithic VM-based, which means instead of having this one giant thing, you had, multiple instances that were all responding to various parts of the system. And so these loosely coupled services, can be developed, deployed, and maintained independently, simple APIs to solve large, complex technical problems. So this was fine too. And I think the next leap we took from here really was from microservice-based applications to Docker or container-based applications. And I just want to make it clear, this is not really a linear progression that happened, or it's not just, no one uses virtual machines anymore, or no one uses microservices anymore. It's just sort of a combination of these things that are now in the picture. And so I think when I think about virtual machines, I would say I think about virtual machines and containers like you might think about trains and airplanes. So airplanes offer you much faster mobility, and then they're just, so easy and convenient. But you're always going to have trains around for journeys that airplanes are not able to handle. So that's how I think about virtual machines and containers. So I don't think either one of them is going to replace anything. It's just they're both specialized to perform specific functions. So the container model, which is, a sort of minimalist approach to application deployment, and they do not require an operating system per application, which is, I think, the advantage that they offer over virtual machines, in that they're much more lightweight and they require much less memory and storage and CPU. So the streamlined approach means that you can deploy many containers on a single server more than you can VMs. So I would roughly say like you could deploy 2 to 3 times more containers than VMs, which is a really efficient way of developing technology. So the Docker is one of the more popular container runtimes. And there are others as well, but Docker has been one of the leading ones for quite some time now. And then finally, Kubernetes orchestrated applications. So this is where we are today, I would say. And Kubernetes in itself is, a portable, extensible, open source platform. What does Kubernetes really do? It helps you manage these containerized workloads and services, which really was the missing part. So there was a lot of complexity around how do you actually manage all of these containers in your system? There was no layer of management. There was no layer of orchestration. And so Kubernetes stepped in to sort of fill that gap. And the name Kubernetes itself actually originates from Greek, which means like a pilot or someone at the helm. And so really that's what it's doing. It's managing all of the containers that are running in an environment. So it originally came out of Google. I believe they open sourced it in 2014. So they've been running it internally, I believe, for over 15 years now. So even when it was first launched, it was quite a mature product, although it definitely goes through consistent iterations. And commonly, as many of you might be aware, we stylize it as K8, so the letter K and the number 8. People use it interchangeably, so Kubernetes K8, it's all the same thing. So what is the actual functionality? I briefly touched on this, but so containers, like we talked about, just help you bundle and run applications, right? But in a production environment, there's so much more that you need to do and ensure like zero downtime and resiliency to the system. So that's where Kubernetes came into the picture. So it's a framework to run your distributed systems resiliently, and it provides users with all of the features listed here. So basically what it does is scaling and failover in a really simple way of thinking about it, provides common deployment patterns. So we can step through some of these. I'll try not to go into too much detail because they can get pretty advanced, but service discovery and load balancing is basically exposing containers to the DNS name or like providing an IP address. So Kubernetes can do all the load balancing. If traffic to a particular container is high, it can reroute to a different container and distribute network traffic. So Kubernetes can take care of all of that. The storage orchestration, so Kubernetes does allow you to mount a storage system of your choice. So this could be a local storage, it could be S3 in Amazon, it could be any such storage backing provider. And then automated rollouts and rollbacks. So Kubernetes is a declarative system, and I should have mentioned this earlier, but what this means is that you basically tell the system what you want your desired end state to be, which is quite different from an imperative system where you tell the system what to do. And so this is a much more kind of like sit back and watch what happens type model, which can be kind of jarring at first. But basically you describe how many instances of a container you want, for example. So if you said, I want 3 containers, and for some reason, one of the containers died, the system is continuously watching the state and it notices that one has died and basically respawns it. So that's all happening in a very automated manner, which is really, really interesting and helps build resilient systems without having to rebuild this over and over again for different applications. So self-healing, this is like I mentioned, restarts containers that fail, kills containers that aren't responding. So it's able to do all of that. And then finally, the secret and configuration management, not really the fun part of application deployment, but you do have to manage passwords, OAuth tokens, SSH keys. So it helps provide all of the management layer around that. So that's the key functionality that's offered by Kubernetes. As to the actual architecture, so this is a very high level view of what the internal architecture of Kubernetes looks like. So on the left, you start with your user interfacing with the Kubernetes control plane. So you can do this via the user interface. It's not really that widely used. I will say most folks tend to interact with Kubernetes through the CLI. I mean, there's nothing stopping you from using the UI, but I think most folks do tend to use the CLI. And here is the Kubernetes control plane. So an entire working Kubernetes deployment, so this entire thing would be called a Kubernetes cluster. And the cluster is composed of 2 main components. One would be the Kubernetes control plane that's here, and then it's your Kubernetes worker nodes that are here. So on your control plane side, you can see there's about 4 boxes in here. So what the control plane does, as the name suggests, is it controls your cluster as well as contains the data about your cluster state and configuration. So it makes sure that your containers are running in sufficient numbers with all of the necessary resources, and the control plane is consistently talking to the worker nodes on the right. So the independent components in here, so the API server is basically the Kubernetes API. So that's what's handling requests and responding. If a request is valid, the API server is the component that kind of process that request and sends them to where it needs to go. The scheduler is detecting constantly whether your cluster is healthy, if new containers are needed, where do they need to get spun up. So it looks at that logic and also schedules it and places them appropriately based on resource consumption. The controller manager, basically, it's kind of the thing that's responsible for Kubernetes being a declarative system. It's always watching every single object, and if there's any changes, it will report that to the scheduler so it can create what's needed. And then the last box here is called etcd, which is basically a key value store. It's storing all of the state of the cluster. And so this is really the brain of the entire operation. On the right, worker nodes are basically, kind of replaceable. They don't really have anything special about them. But all the pods within the worker nodes are representing a single instance of an application. And they are the smallest unit, really, in the Kubernetes object model. Inside the pod, you have multiple containers that can be running. And like I mentioned, the most popular container runtime is Docker. There are a few others. CRIO is a common one. And then the kubelet and kubeproxy are really our internal services. We don't need to get into it, but they ensure like all of the pods are running as they should be. So that's a really quick Kubernetes architecture overview. If you wanted to, you could go really, really deep into this. There's entire books written about it. But I would say on a day-to-day basis, these are the components that you would hear or see about most often. So what makes Kubernetes special? So I think, there have been a ton of open source technologies out there. I would say one of the key things that makes Kubernetes special is that it's been adopted by pretty much every major cloud provider and software vendor in the industry. And if they haven't, they're trying to. So if you look at the Kubernetes ecosystem, and this is really a small snapshot of the whole thing, you can see the public cloud, every major public cloud has a Kubernetes offering today. So just like AWS came out with EC2, which was basically for virtual machine instances, now they have EKS, which is an entire platform for Kubernetes. Similarly, Google has its own container engine, which is where you run Kubernetes. So almost every single public cloud vendor has now a Kubernetes offering. And of course, VMware has its on-prem Kubernetes offering, which is where Aparna and I work. Red Hat is one of our big competitors. They have one as well. And all of these tools here are providing various management, monitoring, logging, security, and functionality for running Kubernetes. Apart from this, a lot of vendors who provide their software are actually now providing their software in containers that is meant to be run by Kubernetes. So we can really see, I think there was an inflection point where everyone decided that Kubernetes was the next big thing. And I think it became a self-fulfilling prophecy to some degree, where now we're actually seeing that happen. So the other factors that make it special, it's built out in the open, which means everything is on GitHub. There's a very dedicated and passionate community that is working on this for essentially, I guess, no profit. Like no single company or entity owns this technology because it's being created in the community. Of course, all the cloud providers I noted do participate and spend a lot of time in improving the code base because it's to the benefit of everyone. And because it's built out in the open, the feature development, the pace of development is very quick, especially because of the active community. And the interface itself, Kubernetes is very, very extensible. So you could pretty much build anything you want on top of Kubernetes. And if you would like to, offer it to everyone that uses it. So pretty much every major cloud provider also has their own interface to Kubernetes that is also typically open sourced. But the ability to make it easily pluggable has made it really, really popular. So in terms of actual use cases, what are we seeing it used for? I think there's a general amount of curiosity where everyone wants to see what they can do with Kubernetes. So even if they don't have a specific use case for it, we've seen a bunch of our customers just want to try it out to see what the hype is all about. But I think one of the key value propositions really is it helps accelerate the build, deploy, and test cycle. And that's just because it's so easy to deploy something with Kubernetes once you have the base infrastructure set up. And containers, again, like I mentioned, are much quicker and lightweight as compared to virtual machines. And so you can easily create them, kill them, and the cycle continues. And it's a lot easier to do that, especially for dev type environments. And then the next one is scheduling and scalability capabilities for AI ML applications. Again, I think there's a lot of need for scaling capacity up and down, especially for AI ML type apps. And it's a lot easier to do that with containers and Kubernetes. And then finally, building and providing services for multiple clouds. So this one, basically, because Kubernetes is an open platform and containers are kind of agnostic, you can run them anywhere. They're not tied to a specific infrastructure platform. So in theory, you could run the same Kubernetes cluster on AWS and Google Cloud. So you could just move them over without any real repercussions or without having to redesign your entire application. Obviously, this is easier said than done, but it's definitely a lot easier to do as compared to some of the application models we had in the past. So this is also proving to be one of the big selling points for Kubernetes. With that, I'm going to switch over and hand it to Aparna.
Thanks, Nikitha. Are you able to see my screen? Okay.
Yeah.
Okay. Yeah, thanks, Nikitha, and hello, everybody. I'm really happy to be here, and at the end of the session, I hope to have shared with you how to go about and get started with Kubernetes. When I started working with Kubernetes, it definitely felt like drinking from a fire hose, and it was intimidating. So the way I would like to go about this session is to provide you with some key concepts, and then we'll walk through how do I get started, like deploying a cluster, accessing a cluster, deploying a pod, create a deployment. And deployment is a really cool object in Kubernetes, and we look at how to roll out a deployment and how to roll back the deployment, some of the zero downtime benefits that Nikitha talked about. And we'll talk about how to expose our application to the outside world. And then I'll end by sharing some insights on how to get started with Kubernetes with least developer friction, and some resources on for reading material and references. So key concepts of Kubernetes, and I think it's important for us to understand these three things. First is Nikitha touched upon that, which is the declarative specification or the desired state. So Kubernetes is a declarative system, and by that we mean we specify the desired state, but we don't specify what exactly that the system needs to do to get to that desired state. And in some of the examples that we'll review, you'll see that we'll have a YAML spec where we actually specify our desired state of our deployment or a pod, but we are not exactly telling Kubernetes that hey, check if the pod status is failed or whatever, then go spin up a new pod. So that's how the system works. So that's one of the key concepts in Kubernetes. And the second thing is called control loops. And we talked a lot about Kubernetes as a self-healing system. And how does Kubernetes do that? In Kubernetes, there are these control loops that are continuously watching different objects and the status of the cluster. And these components are called as controllers. And each controller tries to move the object or the cluster's current state closer to the desired state. And Kubernetes comes with a built-in set of controllers that reside inside the kube controller manager, the architecture diagram that Nikitha shared with us. And each controller focuses on one object or kind of object. And so the cluster is, the one big difference is the state of the Kubernetes cluster is constantly changing. And later in this talk, we'll talk about logging and monitoring and metrics. So that's also, a change from how we may have developed applications and deployed on infrastructures in the past. And the third thing is reconciliation. So there's, in order to achieve the desired state, these reconciliation loops are constantly running, and they are driving the system to meet that actual, from the actual state to meet the desired state. And in the controller runtime, this is implemented by a thing called reconciler. Back to the architecture diagram. So these are the three fundamental concepts in Kubernetes. And with that, so the first thing before we start, playing around and getting started is to create a cluster. And my favorite way to get started with a cluster is to use Kind. Kind is a tool for running Kubernetes clusters locally, and it does so by using Docker as the worker nodes for the cluster. So Kind was primarily designed for testing Kubernetes itself, but it's a really great choice for us to just get started with local development or even our CI pipelines. So as you can see, with one simple command here, I was able to get this cluster, within minutes. And next, we'll talk about how to access our cluster. So in order to access our cluster, we need two things. One is kubectl, which is the CLI that Nikitha talked about. So it's the command line tool that we can download, and that allows us to access the Kubernetes clusters. And the other thing is the kubeconfig file. So the kubeconfig file has the information needed to access the cluster. It's the cluster information, it's the user, and the namespace that the user has access to. And as you can see, this is my Kind clusters config view, and it's pretty simplistic, but in a real, production or a dev environment, it would, look something like this, that you may have like multiple contexts, like, if you're a front-end developer, you can have like a context that is specific to accessing your namespace. And if you're a backend or a developer working on a storage, you can have a context that's customized for accessing your namespace and RBAC settings and such. Okay, so now that we have a cluster, we look at how to look at the various objects inside the cluster. So here in my environment, I have only one context, which happens to be the default, the current context. As you can see, there's a star next to my current context. And by default, kubectl uses the current context to log into your cluster. So I don't have to explicitly specify any kubeconfig file here. So all I'm going to do is kubectl get nodes, and all I have is a single node Kind cluster here. And with this, we'll get started. And the first thing is, we're going to deploy a pod. And what is a pod? A pod is a group of containers with shared storage and network resources, and it contains a specification of how to run the containers. And that brings us to what is a container. A container is the software that we are building. It packages the application code and all of its dependencies, like system libraries that we may use. And container, so when you build your software, you would publish that as an image to a container registry. And when when the container or the pod is getting deployed, it will pull down the image from the container registry, and it will get scheduled on the node and the node is managed by a process called as the kubelet. When a pod gets created, it's scheduled to run on a specific node, and it will remain on that node until the pod finishes execution or the pod is deleted, or there is a need for the pod to get evicted due to lack of resources, or the node fails and it has to fail over to a different node in the cluster. And this is where we'll go ahead and run our pod. As you can see, this is the declarative specification. I'm going to change my, yeah, so this is the declarative specification where we specify, I want a pod, and this is the image to go get the pod from. And I'll go ahead and deploy the pod, kubectl apply. And if you can see, and then I go ahead and run kubectl get pods, I can see that I have one pod running. And what I'll also show you in the next slide is we can port forward the pod, and port forwarding allows us to access and interact with internal Kubernetes cluster processes from our local host. So what it does is it establishes this tunnel from the target pod to our local host. And by doing so, and if we go to localhost and the port that we specified, we'll be able to see that the pod is running. And the next thing this is one of my favorite tools. I mean, in addition to the CLI, Octant is a graphical UI equivalent of kubectl. It's much more than a dashboard. It offers great visibility into the objects in the clusters. You can see that we deployed the quad pod, and we can see all of the the phase, the status, the age of the pod, and various other objects. And I particularly like this view, which is the events view. And you can see that when we just said kubectl apply, it went ahead and pulled the image from gcr.io. It successfully pulled the image. It created the container, and it started the container. So that's this is great for troubleshooting as well. And of course, we can get all of this information from kubectl. And there's also a resource viewer and a YAML editor. And there are also interesting things like object graphs and heat maps that we can look at for complicated deployments. And it shows the health of the overall deployment. Okay, so we talked about deployment. So what is a deployment? A deployment provides declarative updates for pods. And we don't create pods directly in Kubernetes. Typically, we create deployment objects. And in the deployment object, we describe the desired state of the deployment. And the deployment controller goes and changes the actual state to meet the desired state. And deployments, however, doesn't use or create or delete pods directly. It uses something called as a replica set. And what is a replica set? A replica set specification looks very much like the pod specification that we just saw, but it carries this extra field called as replicas. And the replica specifies how many pods using the current specification that we want to deploy. So the way to think about this is deployment controls replica set, and replica set controls pods. And here I have a deployment YAML, and you'll see that I have 3 replicas specified. And the other thing that's interesting to note is there is this label selector. And it's a interesting thing in Kubernetes. The label selector is a core grouping selecting mechanism in Kubernetes, and the match label specifies what pod the deployment specification is going to apply to. So what this match label is saying is I'm going to apply this for pod of that has a name of quad. Okay, so here I went ahead and applied the deployment, kubectl apply deployment.yaml. The deployment is created, and you can see that we specified 3 replicas. So we have 3 pods running, and we have, this is the deployment object, and the last one here is the replica set. Okay, moving on to deployment rollouts. So Nikitha mentioned that the rollout and the rollback are some really cool capabilities of Kubernetes, and we'll look at how this happens. So Kubernetes updates Kubernetes can update our deployments incrementally by creating new pods and destroying the old pods uh, with a zero downtime. And what is this used for? So let's say we have an application and we have made some bug fixes, new features, enhancements, and we have a new version of the applications. Typically, we'll create a new image, provide it a new tag, and we will promote it from one environment to the other, our dev to staging to prod. So that's like one use case in which we'll use the rollouts and deployments. We will go through all the staging environments and eventually make its way to production. And CI/CD use cases. And also the really cool feature of rollouts we'll see in a second is rolling back to the previous versions. Okay, so deployment rollouts. So this is our existing application. It has this image with a tag of 1, and this is going to be our new version. It has a tag of 3. So what I'll do is I'll go ahead and roll out the deployment and say kubectl apply. And what I also did behind the scenes is I created the replicas to be 20, so we can kind of clearly see what's going on. And you can see that there's a bunch of pods that are in creating, and there are a bunch of pods that are in the terminating state. And you'll also notice that there are 2 replica sets here. One is, the age is like 5 seconds, and the other was created, the age is 2 minutes. It was created like a while ago. So the deployment has this really cool feature that only a certain number of pods are down while the rest are being updated. And by default, if we don't specify anything, it's at least 75% of the desired number of pods are up. So for example, when we applied this pod, it does not kill all of the old pods at the same time. Until a sufficient number of the new pods have come up, and it does not create new pods until a sufficient number of old pods have been killed. So that's like the zero downtime automatic deployment rollout feature, and all we did was change that one image tag and said apply. Okay, so what I'm showing here is I went ahead and said kubectl describe deployment, and you can see that there is, there we have our image with the latest tag. And we'll talk about rollback. So, let's say we had a bug and we found that out only after we rolled it out in production. So, and this is also one of the cool features of Kubernetes, where we can go and say kubectl rollout undo deployment quad. And as you can see, it rolled back the deployment. And if I go and now describe the deployment, we can see that the image is back to the old image using tag 1. So this is how we update all, this is how we achieve all the zero downtime upgrades and the self-healing nature of Kubernetes. And so we created an application, and now we have to expose the application to the outside world. So there are a lot of different service types, but we'll talk about cluster IP, node port, and load balancer today. So what does services do? It provides an IP address and port for us to access. It provides a DNS record for service discovery, and it propagates the endpoints using label selectors. And you can see that using the label selector, we can target the apps, the pods that are being accessible by the service. So the first thing is cluster IP. It exposes a service on the cluster's internal IP. It's just, it doesn't offer routability or anything like that. The second one is node port. It exposes the service using the worker node's IP using a static port. We look at that example. And the third and the most commonly used way to expose a service externally is using a load balancer. Whenever whichever cloud provider that you use will typically have a way to create a load balancer, and this is the most popular and widely used method to expose the service in production. And we'll just look at the specification of a node port. And it has the selector. It's providing the service to the quad app. And I can access this by using my worker node IP and the port that we specify here. So a review of what we looked at so far. We looked at some key concepts of Kubernetes, the desired state, control loops, and reconciliation. We looked at how to get started by using kind to create a cluster, access the cluster using kubeconfig, and deploy a pod, deployment. We rolled out a deployment. We had a bug, we rolled back the deployment, and we talked about how to expose the service or the application to the outside world. And some insights on getting started is getting a Kubernetes cluster up and running in the cloud is pretty easy. These days, every major cloud provider has a way to get up and running with Kubernetes. And I believe the biggest gap that we need to focus on is to establishing good developer workflows so that we can have a very reduced friction for developers to go about developing in Kubernetes and deploying using Kubernetes. So the first thing is, if you're new to Kubernetes or your team is new to Kubernetes, I'd say that we focus on new developer onboarding. So how long does it take for a new developer to start from zero to deploying their service on their local Kubernetes cluster? So that's one thing. Having a KPI around that would be great, so we can continuously measure and make improvements. And the second thing is the build test iteration cycle. What's the time that it takes us to get a pull request done? How long does it take to run tests? How long, what is our test flakiness rate? If there is anything greater than 1 in 1,000 tests that are flaky, meaning that it fails for reasons outside of product issues, it can lead to developer friction. And the other consideration to think about is, what is our dev cluster configuration? Do we want to have one cluster per developer or one shared cluster for the entire team? And there are pros and cons to making this decision. One developer per cluster is great. It's great for isolation. We won't step on each other's toes, but the cluster administration can become very hard. And for shared cluster, I think it's a great choice for teams of size 10 to 20. And that way we can have shared cluster services like logging and monitoring. But anything more than that, like 100 developers sharing a cluster, has other set of issues. So that's something to keep in mind. And logging and monitoring are extremely important because Kubernetes is very chatty, and because of the density of the objects and the control loops and the desired state. So one recommendation there is to not log everything. Logs consume a lot of resources and can be very costly when running in your cloud environments. And there are a lot of great tools for logging: Sysdig, Loginsight, and then the Fluent Pit stack. Monitoring, there are multiple layers when developing Kubernetes applications. There's the physical or the virtual environment, the virtual nodes. There's the cluster itself and all the cluster add-ons that we install, and your application. So usage of metrics is important for constant proactive monitoring. And there are a lot of good tools that help us with that. Prometheus, Datadog, Wavefront, they are all market leaders in the monitoring space. And like I said, Kubernetes is it's like drinking from a fire hose. And our recommendations from Nikitha and me are, in terms of Kubernetes 101 tutorials, Kube Academy is great, and Karakoda has a pre-configured Kubernetes cluster, and it's a safe space to just try, experiment. There are like learning modules and lessons. And the greatest resource for Kubernetes is the community documentation for Kubernetes, and it's really great. It's a very well maintained set of documentation for Kubernetes. And another way of really getting to know about Kubernetes is to get involved in the Kubernetes. And I saw some questions earlier on about why Kubernetes is so popular, or like why it's more adopted. And I think it's really because of the community. The community is great. We have a lot of our colleagues who are very active in the community, and there is there is no barrier to entry. They are a very friendly community, so I highly recommend getting involved in the Kubernetes community. And Nikitha, you want to talk about the books and some thought leaders?
Yeah, so the Kubernetes Up and Running, something I read very early on. The author, Joe Beda, is actually now at VMware, but he was one of the founders of Kubernetes. So that was an interesting read. And then some thought leaders to follow on Twitter. Kelsey Hightower, I really like. And I think Brianna mentioned his book in the chat as well. And I think that's a good one too. And then a few other folks here, Jay Beda, that was founder I talked about. This is another Nikitha who's much more qualified than I am, really valuable contributor to Kubernetes, Chris Nova. So I would suggest if you just want to keep up with what's happening, follow these folks and you should be well on your way. So I think with that, we're actually done with our presentations. So we are now open for Q&A, and I think there's a good question here already from Sunita Aparna, which maybe would be good for you to answer. I don't know if you've seen it yet, but I can read it out. The question goes, would you recommend developers use Kind as their local environment when developing on apps that will be deployed in Kubernetes, or should they use something in the cloud?
Yeah, so yeah, let me scroll. But yeah, I mean, I think Kind is great for local development. I mean, yeah, it also depends on your use case, like, what exactly your application does. There may be significant differences between, your production configuration and CI and dev configuration. I mean, in which case it is, it would be problematic. So I think Kind is still a great choice for development. But you may want to consider using your cloud provider or your production like configuration in your CI systems.
Any other questions?
Awesome. Well, we will stay on for a couple minutes if folks want to throw any remaining questions in the chat. But I want to thank you, ladies, for such a phenomenal walkthrough. Your insight and expertise, I think, dropped knowledge bombs on everybody who was able to listen in. Lots of great things. It looks like we don't have any additional questions. So with that, thank you all for attending, and thank you again for some amazing content for us all to noodle on. Are we able to potentially share these slides out with our members?
Yeah, sure.
Yeah.
Perfect. We will get this up on our GitHub repo and share that link in the Slack channel. If anybody needs the link to Slack, you know how to ping us and email us. But that way we can all, maybe if you missed screenshotting those resources, you can go back and look at the walkthrough and all the different notes and points that they brought up.
Okay, thanks everyone.
Thank you.
Bye.
Perfect. I'm going to close our session. Everyone have a fantastic rest of your day.